So what we are presenting today is basically how we use Traent technology, which is an hybrid blockchain platform, to create a product passport for the battery and for the automotive sector. We will try to have this conversation in a way that we highlight the most fundamental piece of our solution, our technology, because we think we have a different approach to blockchain in general, and I think that it could be interesting to show some of the results we developed and some of our research. We are very happy to collaborate with all the blockchain company out there and automotive company that wants to interoperate with us. So I hope that at the end of the presentation, you will have a very clear understanding of what we do. So today's agenda is it's made of, first we start with the requirements that we think are very important for the enterprise to use and implement blockchain projects. So most of the requirements are not available on classical blockchain like public blockchain. So we will try to identify those requirements, and then we will show our approach, and we will discuss if we met those requirements. So if we satisfy these requirements, then we'll go very fast on the enterprise use case, which are mostly related to product passport and battery passport, and then we'll have a QA session. So my company Traent was founded 3 years ago by me and Federico D'Annunzio. It's a company in Pisa. Pisa is a very small city in Italy, but a city that is full of students and bright minds. We have 3 universities, 60K students there, and a very active community of developers. And what we do is basically we create very easy to use blockchain solutions that are real time and support data intensive communication on blockchain. And in the last 3 years, I led the research team of 6 people and the development team of 15 people. And we produce interesting research. We submitted 8 patents internationally, and we published some scientific paper, but most importantly, we developed a new ecosystem, which is an ecosystem for transparent and sustainable enterprises that is based on blockchain. So it's a Web3 ecosystem. So, when we start, we try to address the most difficult problems in the supply chain management, digital product passport, ESG data platform, and dealing with the IoT devices and the IoT data streams. And all of these problems has something in some requirements in common. So if you want your communication to be trustworthy and reliable, you need to have authenticated peers. You need to have a solution that is privacy preserving, because you cannot, of course, put data on a public blockchain or all the data on a public blockchain. So you need to have privacy, but you also need that this data can be disclosed. So, and we will talk about this concept. So we basically read down 6 very important requirements for us that we must satisfy. So first one, the requirement number 1, all actors should be authenticated. So the actor should be identified, and the data managed by the system must be non-reputable by its authors. So this is typical in a private blockchain environment. So we address this requirement. Then we need to have this data the system must able to limit the data access. So if you put data on the blockchain, this doesn't mean that everybody in the world has access to this data. So similar to a private blockchain, we have limitation on the data access. The requirement number 3, it's very, very important for us. So the system should be suitable for as the main data layer for data-intensive and real-time application. This means that if we want to connect the car, we want the data from the car in real time. And sometimes the data you want to store on the ledger could be gigabytes and gigabytes or even terabytes. And this should be not a problem with our solution. Then we have the requirements of disclosability. So we want that people and organizations are able to disclose the data produced inside the system to external actors, such auditors, customers, consumers, and we want that the data that is shared, even outside the network, so even outside your private blockchain, maintains the ability to prove its integrity, its authenticity, and the consistency of the data. Another requirement we wanted to address is the erasability. So I know that this can be perceived as strange, but in order to be compliant with the GDPR requirements, data, even though the data is stored on a blockchain, you want the data to be erasable, because you can put data on a blockchain because of errors, or you want to be compliant with Article 17, so the right to be forgotten. And we allow this, we introduce a notion of practical immutability. That means that you can erase data from the blockchain, and we show how, but you leave traces when you delete data. And the last one, that for us is the most important one, we want the user, the system, must offer user-friendly interface, user-friendly data visualization, and that the user doesn't need to be an expert of blockchain technology to use our platform. So before talking how we address these problems, it is important that we are all on the same page. So we will be briefly explain how our technology fits in the current landscape of blockchain. So you know that you have a public blockchain, usually are permissionless, where everyone can be a participant, everybody can do everything, so read, write, and validate blocks. And then you have private blockchains, so the most used blockchain for the enterprise, where usually are very similar, like conceptually, to public blockchain, but the access to the data is restricted to only allowed nodes. And usually some nodes are more special than others in this kind of blockchain. And this limitation on the operation you can do and the data you can access on a private blockchain makes all the difference for the end user. Because if you use a public blockchain, you know that is the most immutable and transparent blockchain out there, but you usually have performance problems, like to put 1 megabyte of data into Ethereum, it will cost you 3 days of work, and from 40K to 500K. And you cannot remove the data. The performance of the network is usually very slow, so you can only do tens or hundreds of transactions. And you have this forced transparency. So if you put something on Bitcoin, if you put something on Ethereum, everybody can see it. You cannot remove it. So it seems that the the solution for the enterprise is to use a private blockchain that allows for faster transaction, and you can restrict the access to the blockchain, but they are less secure. And mostly the most important problem is that they are not auditable from external actors. So if you are not inside the blockchain, the private blockchain, you cannot verify the data. And if I show you the data from a private blockchain, you have no tools, no software, no cryptography to verify the data that is stored in a private ledger if you are outside the ledger. So how we solve this problem? It's basically creating an hybrid blockchain. So we put together the best of the public blockchain, the best of the private blockchain to bring for the first time real-time and data-intensive application on blockchain while preserving the confidentiality and auditability of the data. So we built this ecosystem that has some interesting new concept. The first one, the hybrid structure, the hybrid infrastructure, it's not made by one or few blockchain, but it's made by billions of blockchain. So in our platform, it's very, very easy to create a blockchain. It requires you 1 click and 50 milliseconds. So you can create a blockchain and doesn't cost you anything. So you can create a blockchain for each product, a blockchain for each battery, a blockchain for each customer, or even a blockchain for each part of the car. So it can be very, very extreme. Then you have this application that I will show you in a second. It's called Traent that allows you in real time with user interface or APIs to gather reliable data from people, organization, and IoT device. This data is stored on what we call a portable ledger. And the portable ledger basically allows you to do an operation that we call granular data disclosure. So basically, in the case of a car, you can, I can share, I share all the information about the maintenance of the car, about the mileage, how many charges I have done with the car, but I can select, I can decide to not to share in which location I recharged the car. So this concept of granular data disclosure. So you can say, okay, I want to share this field, and not other fields. And who received the data can access this blockchain, which is a portable blockchain. So I can send you via email, I can send you via WhatsApp, I can put this blockchain on an application or on a website. And using an application that it's called Traent Viewer, you can show this data from the blockchain, authentic data, in a way that is interactive and interesting for the user and easy to use. So our key different approaches, our key difference with other blockchain approaches. So in our blockchain, there is no blockchain. We don't have one ledger, but we have billions of ledgers. We don't have transaction, so our transaction is a block. So we don't collect transaction, create a block, and from time to time share this block with other peers in the network. Every time you want to add something on the blockchain, you create a block, and it's instantly shared with the people that you want to share with the data or the organization. We have not one single rule or policy for the entire network, but every blockchain has a customizable ledger policies that is specified in the first block. And in the ledger policies, we put information like how, which kind of encryption algorithm we use, how we sign the contract, who is allowed to access the data, to write the data, and so on. And with that said, we don't have block times. So like in Bitcoin or Hyperledger, we don't have block time. So we don't wait 10 minutes and then we add the new data. All new blocks are instantly appended and distributed to the blockchain. So these allow us to be really, really fast and support real-time application. For what concerns the consensus algorithm and the block ordering, so the blocks are ordered by a service we call the vault, we will see in a minute, according to the policy of the ledger. We allow the user to select different policies, like to maximize fairness or minimize latency or maximize the throughput, but we have one node that is shared by the participant in the blockchain that will order the nodes, the blocks according to the policy. And the consensus algorithm we use in the public blockchain is a proof of stake algorithm, because we use Algorand to notarize notarization consistency proof. I will explain in a second. The private network has a new concept, a very interesting concept of consensus, which is asynchronous and is built at application level. We call it acknowledgement blocks. That are blocks created by the participant when they need to agree on a content of the blockchain or on a decision and so on. And with that said, our architecture is fairly simple. So it's divided in 4 main areas. The first area is made by user-facing apps. We will see Traent, Era, and the viewer. Then you have an area of customer infrastructures. So every customer has one node that is deployed in his infrastructure. It could be Amazon AWS or even on-prem. Then we have the Traent infrastructure. They are centralized system, like for the identity. So everybody in our system has an identity that is given by Traent. And so we have this identity server. It could be federated, but for the moment is centralized. And then we have other systems like the notary. The notary is the system that is the bridge. It's the bridge for the private blockchains, the billions of private blockchains, and the public network. It could be also hosted by you. So we support federated deploy of the notary. But anyway, the last part is made by the third-party architecture, the third-party system, which of course are made by the public blockchain. We use Algorand, and we have also another system, we call it Monitor, that is able to verify all the transaction in the system, but mostly it verifies the notarization of the transaction of all the ledgers. So this is our high-level design of the system. So it is very important to the right part. So the right part is your node. Every company has at least one of these nodes, and it has an app, which is Traent Era, a backend that we usually call it OrgNode. And the interesting thing about this OrgNode is that the storage layer is not based on a traditional database, but it's based on a blockchain ledger. So whenever you create a project and you share a project with someone, you are actually creating a blockchain that is shared amongst some participant of the network that are the participants that are allowed that participate in your project. So not all the ledgers are shared with anyone in the system. Usually the ledgers is only shared between your peers or the company you collaborate with. So if I have a project, I am from Acme and I want to share a ledger with Mobi, those are 2 different organizations. We will have one ledger which will be identical. Whenever I want to put data on my ledger, I will add a block containing the new data, and this new block will be also distributed to Mobi. Okay, so Mobi will have, as soon as possible, we'll have a ledger which is identical to the ledger that I just modified. And when we do so, we also send the hash of this new added block to a service that it's called immutability. So Acme creates a new block. The immutability knows who is interested in knowing about new blocks in this ledger, in this case Mobi. So the immutability will notify Mobi to download this block, and the block could be distributed by the OrgNode of Acme itself, or can be downloaded by the Vault. The Vault is a service that basically stores a copy, an encrypted copy of the data, so you can access directly through the Vault if you convince the Vault with that zero knowledge proof that you know the private key of the ledger. So basically, whenever you want to download data from the Vault, you prove that you have access to this ledger, and the Vault will allow you to download the most updated version of this block. And this is why our system is so fast. So there is a bit of centralization here, similar to an ordering node on Hyperledger, but this allows us to be very, very, very fast. Then this information about the new block that was added is communicated to the notary. The notary we will see in a minute, but he creates proofs of authenticity, consistency, integrity of the data, and does this creating a proof that we patented. We call it Ledger3, that is stored on a public storage. So this public storage is not a blockchain, it's a public cloud storage. Everybody can access it. But the interesting thing is that this proof, it's a verifiable data structure. So we put an hash of this data structure periodically on a public blockchain. So who has the needs to verify the data and has access to the portable ledger can use these proofs and access the public blockchain to verify the proofs. So I will explain better how the system works, but basically a system like this allows you to create for the first time a system that scales, a blockchain infrastructure that scales horizontally. Why is that? Because you are not using one single ledger, you are creating many ledgers, and you will only store the ledger you are interested in. And also, if your nodes needs to process more ledger, so more data, you can just add the new nodes that manage only a subset of these ledgers. So to make it more clear, if you are going slow, if you are using Bitcoin and Bitcoin is slow or Ethereum is slow, usually adding new servers will not improve the latency of the system, the throughput of the system, because everyone has the same ledger. So we say that Bitcoin and traditional blockchain technology only scales vertically. So only scale if I use more powerful computers, more storage, more RAM, and so on. But there is a limitation, a physical limitation, how powerful you can make a server. And of course, if you allow user only to use the most powerful computing resource, it's not very decentralized. But if you split your information in many different ledgers, and you have your nodes only dealing with the information they need to, and if you are going slow and you need more processing power, you can add servers that deals only with certain ledgers. This makes the system scalable, really, really scalable. So, and this is high level how we scale our solution, for instance, using AWS. So basically we have these application load balancer that takes all the input from the users. Then he asks the relevant OrgNode to process the transaction or the operation, and the OrgNode is based on a storage layer that scales. So because we use Redis for in-memory operation, and you can deploy Redis in clusters, we use Postgre to store data about the metadata of the blocks, and you can, of course, deploy it in clusters, and we use AWS S3 for the big files, and of course AWS S3 scales and Azure Blob scales. So we are agnostic. You can use Azure, Google Cloud, or AWS, or even on-prem, but this is how it works. The same things apply to the Vault. So you can scale out as many instances of the Vault you need. And about the ledger data structure, I explained that we support this granular data disclosure, okay? So I cannot really go into the details, but just to give you, just to explain you how it works. So how I can share with you, for instance, that I made an order, that I am a certain buyer, that I paid, that I shipped to a certain address, but I don't want to share with you the price I paid for instance, for a product. So we made, in this example, we have the ledger layout. So the first part is what we call the chained blocks, so the blockchain. So first block is the policy that says, oh, those are the authors, so the organization that are allowed to write on this ledger. Then you have the first data block, the block number 2, that says that you have a data, which is an order that was made by a buyer, which is H0. So it's not the person, the name of the person, that has, but is an hash to a block. Then you have the price, which is H1. So if I want to share with you that basically all the information, but I don't want to share the price, I just share with you all the blockchain, all these blocks, but I will not share with you the block H1 that contains the price. So this means that you will not have really the access to the information. So it's not like I encrypted the information with the key you don't have, okay? No, you don't have the information. Why this is so powerful? This is so powerful because you have all the information in the same database, let's say, but it's organized in a very granular way, a way that allows you to select only the information you want to share in a very, very granular way. And why it is this performance? So because here we are encrypting every data with a different encryption key, and we are putting this data in a different block, but it's in the same system. Yes, it's very, very fast. We can write more than 250 megabytes of off-chain blocks each second, and this allows us to be real time. Alongside the chained blocks and off-chained blocks, we have other data and metadata, but the most important data that we have is the notarization consistency proofs. This is the proofs that is created by the notary. So at regular intervals, the notary creates this huge proof that it's basically gigabytes and gigabytes of data. But remember, this proof is not stored on a public blockchain, it's stored on a public storage, and this proves is an auditable data structure. So similar to a Merkle tree, okay, if you verify the root of this data structure, this means that all the information of the data structure is also verified. And this data structure is, in some sense, is similar to a Merkle tree, and we call it ledger's tree because you can explain like a tree of Merkle trees. But basically, the most interesting things about this is that this data structure has two very important properties. One is self-contained, and the other one is that it is compact. What does it mean? It means that if we have a project together and I send you 10 PDFs, 1 megabyte each, the size of the blockchain will be roughly 10 megabytes. Then we add this notarization consistency proof that is usually less than half a megabyte. So you have 10 megabyte and a half, I can send you 10 megabyte and a half. It's different from, oh, I put this document on Bitcoin, on Ethereum, I will send you Bitcoin, okay? Doesn't make sense. But with this, you have this very lightweight ledger that I can send you, I can put it on your website, and this proves it self-contains because it contains all the information you need to prove that your data has been not tampered with. And of course, it's compact because it's only half a megabyte. And the interesting thing is that we developed what we call notarization consistency proof, which is different from a usual inclusion proof of a Merkle tree, but allows you to basically prove that your data it's consistent with the notarization that is made on the public ledger. So with that said, now the technical part is over. Let's see the applications. So first application is our collaboration platform. So now we have support for real-time communication and data-intensive applications. So I can put videos, I can put data from IoT. So we created an application that it's Traent Era, which is like a Web 2.0 application. So everything you do, it's done in real time. You can share documents, you can have discussion, you can integrate data from IoT, you can do in a visual way or even through APIs. You can create views, you can have projects, and these projects are basically regulated by workflows, so smart contracts. So, and what is interesting is that you have this application that allows you to create this project. A project is like a container of document of any type, real-time dashboard, discussion, data from the IoT. You can have any kinds of document you want. If the document has some fields, we call it data streams, error streams, they can be updated by people or IoT device from the connectivity of the car through an API. And everything you do, it's stored on the blockchain and notarized in real time. So finally, you have this seamless integration of IoT and blockchain. So you have this nice user interface, everything updates in real time. You can customize it, you can create dashboard, you can have the discussion, and you can have process. So we have a workflow management tool that allows you to create new workflows that are smart contracts. So basically, in this case, we have this smart contract. It's called waste management cycle. Is in the state finalized. In this state, you can do some operation, not other operation. You can go in review by clicking in this button. You can go back if you are allowed to. every participant in the system has different permissions, and these smart contracts are created using a powerful tool that has two very interesting characteristics. The first one is a no-code smart contract editor. You can go you can open Visual Studio Code, go to extension, you search for Traent editor, you will find our extension that allows you to create a smart contract for our language in a visual way. And the other thing is very powerful. It's very powerful. So for instance, the workflow can create documents like PDF documents. It can execute machine learning models. We have a blog post in our blog that explain how you can put on blockchain a machine learning algorithm made with Google TensorFlow, which is de facto standard for machine learning models. So it's very powerful. We even once run a video game on it. We run Doom, the video game, in our smart contract engine. You can find more on our blog. Everything is detailed. There is also a video, everything explained. So comparing to other smart contract solution, this is very, very powerful because it can automate process, can create resources, it can integrate IoT, RFID, and you don't need a PhD to use it. So everything is very, very easy to use. And with that said, it's our system is very similar to a BPM tool. So you have state, transition, and action. We don't really have the time to talk about it, but I suggest you to take a look to our documentation on our website, because everything is explained in simple terms. This is our workflow no code that is integrated with the Visual Studio Code. If you want to have a look, if you want to try, we can give you a free trial, or we can discuss it further, but it's very, very powerful. And the last concept I want to show you is the viewer. So you saw ERA application. Now we can see some solution built on it. So basically, you gather the data using Traent ERA APIs or Traent ERA software. Then you choose what you want to share from the ledger. So basically, you can, if you have data from the car, you can say, oh, I want to share the mileage. I want to share the maximum speed, the average speed, the state of the batteries. You just select it. Of course, you can automate this procedure, but then after you do this, you obtain a ledger, a copy of your ledger with usually less data from the original ledger. You can automate this process, and then you have this viewer that allows you to see the data from the blockchain in new, meaningful way. So if I'm talking about CO2 emission, I show you a beautiful graph that explains how my emission are lowering through the years, or I can show you videos, or I can make interactive applications. So for the user, it's very, very simple to use. For the auditor, they can have access to all the data because you can repeat this procedure many times. For the tech people or for the paranoids, they can access all the data in the ledger. But the interesting thing is they are doing it in their browser in real time using a web application that is built with WebAssembly. So they are not really accessing another server. They have the data, they access the data, they show the data and verify the data in their browser, and then they will connect to the public blockchain to verify the proofs. And if everything is okay, the data is showed by the UI. About the satisfaction of the requirements, this will be very, very fast. Are we meeting the requirements? Authentication, yes, of course. We do the KYC. We verify organization and people. The privacy, all the data, it's private. You can decide with granular data disclosure which data you want to share with whom. The performance, off-chain data writes are very, very fast, more than 200 megabytes seconds, and you can share data in real time. Disclosability, yeah, combining the granular data disclosure, the viewer, and the fact the data is stored on the blockchain, you can basically show only the data you want, or maybe show to the general public part of the data and to the auditor all the data, or your partner most of your data. To be fair, we didn't implement at the moment the possibility to prove the deletion of the data. So you can delete data, this will leave traces, but the making of a proof deletion is still work in progress. So we can erase data, but to prove that we have deleted data, it's still work in progress. Usability, you saw really easy to use workflow editor, collaboration platform, and the viewer. So I think it's pretty usable. So about the use case, we will mostly talk about product passport and battery product passport, because we also have some demo to show. But I want you to understand that if you have a blockchain platform that allows you to create as many blockchain as you want, you can basically partition your data for every component. So if you want to build the next battery, and you have a different supplier, one for the motherboard, one for the cells, one for the hardware, and so on, you can put all your suppliers in different blockchains, so they don't see each other data, but you have all the data, and they can use granular data disclosure to disclose maybe only they will deliver on time, but not their sourcing price or other confidential information. And with the viewer, you can have this information updated in real time, so you can have detailed tracking by component. You can do risk visualization in a way that is very, very efficient, because each project, each component can have different workflow. So if you look at the battery, you can see that it's in production because you have some missing pieces, because the electrolyte are in quality assurance, and the cell container is in production, so you are missing some part, and you can be notified in real time. With that said, it was important because data from the product passport can be integrated by the supply chain, but this is our core. So what we mostly do every day is to create a digital product passport that aligns with the European Union requirements for digital product passport, that will be a requirement not only for fashion industry, automotive, but basically any company selling product in the EU market. How we do this? So we prepare a live demo. This is our portable blockchain for the automotive industry. So if you scan the QR code, you will see the interactive demo. You will download this blockchain on your phone. It will verify the blockchain on your phone, and then it will show you data. This is just an example, but it's very important to understand that it's very, very flexible. So you can put data from the car. You can integrate features of the car, like locating the car, unlocking the car. You can put the data from your battery passport, so you can prove the state of the health just sharing your blockchain. You can show or share how many times you charge the battery. You can sell the battery, and who's received the battery will also receive a product passport. So you will have a second life and recycle instructions. You can have maintenance program. You can show carbon emission of your car based on the usage of your car that are stored in real time on the blockchain. And we just released the first product passport for the automotive. So if you scan this demo, you can see a preview of it. It's not the final version, but because it's on a preview phase. But we are working with the Kelliker, which is one of the biggest car dealer in Italy that imports Mitsubishi and other Japanese and Chinese brands to Italy. And they will notarize the history of a new car and used car using our blockchain solution. And if you are wondering how we can bring the data to the blockchain, we have different means. We can gather this data from the brand owner, from the car manufacturer, from their system, but we can even do this data gathering in real time from the car. So this is a demo I want to share with you about the real-time capabilities of our system. So basically on the left, you have a simulator of a car that is basically pushing data every 50, 100 milliseconds to the blockchain. And on the right, you have a dashboard that we created, a personalized dashboard that we created for Traent era, that is basically showing this data coming from the simulator in real time. And this is an interactive application. This means that you can click on this electric fuel information. You can see the status of the battery in real time. Now the battery is discharging. You can see the health of the battery. Of course, everything is simulated, but it's not different from the actual product. And this where general data disclosure comes handy, because you can share this ledger. So I can share how many times I charge the battery, but I can select not to share the location of the charging sessions. You can put maintenance and everything. But the very interesting thing is now in this demo, we will show what is behind, which is ERA. This is the platform. Now my colleagues that has recorded the video is showing the data stream. So you can click on the mileage, for instance, and you can see the full log that was pushed on the blockchain every few milliseconds. So with all the data. And now my colleagues will show you how many data we pushed in the blockchain in 1 minute. They are almost 300 blockchain blocks. And last but not least, now my colleague will show you how we do the granular data disclosure, and we show the data to the end user. So it's doing the data granular disclosure. This project is made by 2 ledgers. One for the data of the engine of the car, and one ledger that stores the data about the battery. So basically, my colleagues selected all the data you want to share. For simplicity, the second export will be full. And so this is the 2 ledgers. Now is exporting the data. Now in a minute it will be ready. So you download the ledger, and now you can put the ledger on the viewer. So it will use drag and drop, but we can provide links or QR code. The data is verified by the browser, and then a beautiful interactive application with the data from the simulator is shown to the user. It's interactive, so you can not only show the data, but also ask new data from the user. The user is allowed to share this data in different way, doing the granular data disclosure from his phone itself. So I hope that these explain in a very easy way how powerful is our system, how having the possibility of putting data from the IoT in real time, huge amount of data, even terabytes of data, change everything. And of course, you should not be worried about the cost, because it doesn't cost you anything to add data on the blockchain. There is no transaction cost. But of course, if you want to put less data, okay, you can, even if it's very simple data about the battery status. Maybe it's not real time, but once a week, once a month, or once a day. I want you to know that it's something that you can do it today, that it's very well documented on our website, that it's something we can implement together with the Mobi community. And I hope that this will push and show how you can create product passports that are easily accessible, easily understandable, and used by end customer today, not in a few years. Thank you.
Thank you so much, Fabio. We have about 5 minutes, so we'll be able to take just a few questions. Does anybody have any questions for Fabio? Please feel free to either send a message in the chat or go ahead and unmute yourself and ask. Going once? Going twice? Well, very explanatory presentation. Fabio, thank you so much for your time with us today. We appreciate you coming out and delivering this talk. Thank you to everybody for joining us today. We'll be posting the recording of this on our website, so keep your eyes out there. And we look forward to all of you joining us at our next webinar. So
thank you. Feel free to add me on LinkedIn and continue the chat in the next session or product passport session, Mobi session, and let's keep the conversation going. Thank you, guys. Thank you for all your attention. Thank you. And thanks Mobi.